Okay, I was talking about this GitHub. This is a very huge, large community for the कंप्यूटर डेवलपर्स, जहाँ पर कंप्यूटर्स डेवलपर्स जो है वो अपने different projects पर या different functionalities को कोड करके यहाँ GitHub में submit करते हैं, ठीक है, for the reusability for the other users. In the same way, we are the users, so we just want to get the complete package of this file tools. So we will just install this GitHub and from this package. I have done it. It will take some time and will give you this type of result. Okay, so your package is installed successfully. Now you can start your work. So just first of all, these are the packages we have installed on our uh, platform. Now we have installed critical, like these 4 to 5 types of packages we have installed. Now the most important core package from Phylogenetic in R is called APE. APE is basically stands for analysis of phylogenetics and evolution in R. As we were studying about the topic of phylogenetic analysis, so this APE tool is the more core package in the phylogeny. So now our first step is library APE. We will just we can clear this console with Control L. We will load this library APE. Okay, APE does many different things to get started. Let's read. This is a toy example vertebrate. Uh, Example of vertebrate. These are all vertebrates. Tree from the Newick text string. Newick text string is basically a format like csv.txt. This is a kind of a format of the text string in Newick format. Okay, so this is the Newick format. Okay, now what we have to do, read the tree from the string. We will read this string and paste it on. Okay, now you just have to paste your text.string Newick format, and your next command is this word tree to read from this command. Okay, we have done this process. Now we have to visualize this phylogeny tree. Okay, let's plot the phylogeny in 3 different styles. We will plot this phylogeny tree in 3 different styles. This is the plot command. So here is your result. Okay, now you can see the close relation of pig and cow. All these species are vertebrates. So pig and cow has the closely relation, and this pig and cow has the relation with the whale. This is a one cluster, and this is another cluster. Human has a close relation with the lemur. Lemur is also kind of monkeys or chimpanzees. So with this, bat has a relation with this cluster. It means that कि human और lemur के दरमियान जो genetic relation है वो बहुत close है, but bat is also related to them, but it has the differentiation in the genetic material. So in this way, this iguana and robin has the similar genetic material, and these are the out groups. Okay, so our next task is, this was our first tree. Okay, now we will load the library file tools, and then we will round phylogram bird dot tree. We want to draw our tree like this. This is our another phylogenetic tree. This is a very fancy phylogenetic in a round shape. So we are just visualizing the tree. Okay, now our next step is unrooted tree. We are going to construct with this command. Close the plot view. This is our unrooted tree. We have studied about unrooted tree in the neighbor joining algorithm. Okay, our next step is okay, word tree. In word tree, what you will get in the output phylogenetic tree will have 11 tips. 11 tips means 11 leaves, child nodes, and 10 internal nodes in it. And tip labels are cow, pig, whale, bat, lemur, and human, and up to so on. Okay, and this was the rooted tree, no branch with no branch length. Okay, so our next step is um, this start tree. List of 3 edges. ये 3 की आपके पास लिस्ट है. This is edge, node and tip. Edges जो है वो आपके 1 से 20 है, 1 is to 2 internal nodes के, और nodes हैं internal nodes 10 है. tips की जो labeling है वो ये है आपके पास. और now we will do another command, that is this one. For this, what we are going to do to understand the structure of a philo object a little bit more clearly, let's read in much simpler phylogeny and then decompose it to its essential components. हम एक जो है smaller जो tree है वो construct करेंगे, and then we will try to understand from it what is the structure of philo object. Then plot the tree with this command. This is our tree. We have the nodes 1, 2, 3, 4, and 5. Okay. So our next step is label tips. And then node labels. Okay, basically the previous command was giving an error. I had closed it. Okay, this is my tree with having A, B, C, and D, and E leaves. Now my second step is I have to get the number of tip labels. I will just label the tips. Tips are basically the child node, and I'm just labeling how many nodes are there. 1, 2, 3, 4, and 5. I've just labeled the tips. And now second one is this is node labels. पहले मैंने आपको जो टिप्स हैं child nodes उनको label किया है. Now I'm going to label the internal nodes. So these are the internal nodes 6, 7, 8, and 9. Okay, my next step is tree edges. Okay, 1, 2, 3, 4, 5, 6 are the. This is basically the hierarchy. Our root node is 6 and 6 से आपका 7 का नोड है, देन 7 से आपकी 8 की नोड है, 8 से आपकी 1 की नोड है, और 8 से आपकी 2 की भी नोड है, देन अगेन नाउ 7 this 7 has been completed. Now the other one is 7 से आपकी 9 की नोड है, ये देखिए 7 से आपकी 9 की नोड है, और फिर उसके बाद 9 से आपकी 3 and 4 की नोड है, and then 6 की 5 so this is a hierarchy of your tree. Okay, our next step is the other component of importance. The other components of importance are the vector, tip, label, and an integer node, which gives the number of interior nodes in the tree. So with this command, what we will get, tip label, A, B, C, D is the label of the child nodes or leaves, and this is the internal nodes. There are 4 internal nodes in this tree, and our next step is we can also write and read the phylogenetic trees. If we have any file to read, then we can also read it out, and we can also write in the particular tree. So we have this file, just like an all dot tree. We are having this tree. Okay, what I will do, I haven't downloaded it, but I will use it through the URL. So I will just paste it here, and I will use the URL of this link. This is the Nubic style, and I will just use the URL of the okay. Okay, I have just read this file from the URL, and now my second step is to open this command. Okay, a knowledge dot tree in which there are 82 tips and 81 internal nodes. This is the table tips of labeling of the tips, and this is the rooty tree including branch length. अब आप यहाँ पर देख सकते हैं कि we will just construct it. Okay, I'm just plotting this tree with this command. This is just giving you the phylogenetic tree of the knowledge dot tree. Okay, now this is a tree containing n tip. आप इसकी tips को calculate कर सकते हैं. If you want to calculate its tips, this is 82. Okay, and you can also write on this on any file, write dot tree file name is example dot tree. This is written, and you can just okay. और आपका जो ट्री है बेसिकली आपने क्या राइट किया है, A, B, C, D and E with these number of nodes. These are the child nodes. Okay, in the same way you will construct uh, for the same data knowledge tree, what you can construct, this is the unrooted tree. Okay, so this is very interesting work to do. Now I'm going to construct the circular tree. Okay, this is the circular tree, but having this is the rooted tree. This is the root and having different branches. So the other one is you can just check the um, like you can delete any species from it, or you can add any species, or you can just prune the, like you can just try these all commands for your to understand the phylogenetic analysis. So this is your time to practice about all this. So there is another exercise I have already given into your teams teams file folder. I have uploaded this PDF file where you can find this introduction to phylogenetic analysis using. This is very interesting, and you can see there is a table content. You can understand the introduction, and we have just done this part, distance based phylogeny. So just stick with that and do the practice from here. Okay, we have just done this step, so we will just try to run the commands for on the. Okay, so there is some given data, you can use it or read it from this URL and try to practice all these commands, and you can draw very extensive and very nice graphs or charts. This is the heat map. This is a simple NJ tree, neighbor joining tree, which we have already done, and unmuted neighbor joining. Okay, you can just try out these commands. This is the molecular evolution from root to descendant. You can just try out these very interesting graphing of phylogenetic analysis. Okay, thank you students. I hope you have understand all such process. So try it out, and you can it will be helpful to you in other subjects as well. So thank you. This is all about today's lecture.